So now let us talk about the RDS. So RDS is going to be small at the exam in the Solution Architect Professional. We just need to know how many engines there are. So by now, hopefully you should know them. So there's a post where like SQL, MySQL, MariaDB, SQL, and Microsoft SQL Server. So it's a managed database. You need to provision the servers. Now you choose like the instance type, and then you get a bunch of things that out of it: automated backups, patching, monitoring, and so on. You usually launch your RDS database in a VPC in a private subnet, and then you control access to your database using security groups. And remember, when we have a Lambda function who wants to access our RDS database, we have to launch it into a private VPC subnet so that it has communication with our RDS database. The storage by EBS is provided as a form of GP2 or IO1, and you have the option to increase the volume size automatically with auto scaling. You will use GP2 volume if the place like performance is enough for you, but in case you have high IO requirements, then IO1 may be a better EBS choice. For backups, you get automated with point-in-time recoveries, and the backups will expire, and the snapshots are very similar, but they are manual. Okay, in which case you can take a backup and have it in point of time or how many years you want, and it's possible for you to take these snapshots and copy them across regions, which is very helpful when you want to have disaster recovery. And RDS also publishes a bunch of events, so what's happening to your database, so you can get an SNS topic that will contain all the events for your RDS. It's called RDS event notification, and this could be for operations, for outages, for when the backups are beginning, and etc, etc. So here's another concept that you should know by now. There's a multi-AZ in which you have the standby and the instance for failover in case there's an outage. So we have a master RDS database and one availability zone, and it's going to be synchronously replicated to another standby instance in another AZ. So availability zone B, your application only accesses your RDS database through one DNS name, and that DNS name will change automatically in case of a failover. And so that means that your standby database is never accessed by your application. Only your master database is accessed. Okay, and there will be reads and writes happening directly solely onto the master instance. So here multi-AZ is really for recovery. In case of outage, it's a backup database, it's a standby database. Okay, but our application never uses it. And if we wanted to scale the reads, then we would use the read replicas. So these read replicas are going to be like synchronous replication. So we have eventual consistency, and then can be created across regions, cross regions. So it's possible to use replica to reduce the latency in different regions in RDS. So your RDS instance will have an asynchronous replication into another RDS replica, again same region or different region, and then your application can do reads and writes into your main RDS database, but can also do reads only onto your read replica. So this is why it's called a read replica. So in terms of security, KMS encryption is available for your underlying EBS volumes and snapshots. You get transparent data encryption, TDE for Oracle and SQL Server. You get SSL encryption for RDS for database in-flight calls, and if possible, you could enforce it. IAM authentication only works for MySQL and PostgreSQL and authorization. Even though you are authentically with IAM, it still happens with RDS. So you still need to define what users can and cannot do inside of your RDS database. IAM cannot help you with that. Okay, you can create an encrypted RDS snapshots from an encrypted RDS snapshots. Okay, so that means that you can create an encrypted RDS snapshot from an unencrypted RDS snapshot. So that means that you can encrypt an unencrypted database through the process of snap sorting and CloudTrail. So as a general reminder, uh, CloudTrail cannot be used to track queries made within RDS. We have also seen it earlier. So next, we have the RDS specificity. So RDS specificity for Oracle, and I wish I didn't have to learn them because it's quite boring, but you have to, and they can come up at the exam for 1 or 2 questions. So let's talk about them. Let's talk about backups. So you have two ways of backing up an Oracle database. You have RDS backups and then something else called Oracle RMAN. Recovery manager for backups and restore to non-RDS. So RDS backups are used to backup and restore to Amazon RDS for Oracle, whereas Oracle RMAN recovery manager are to backup and restore to non-RDS. Okay, RDS is not supported. So a graph will help. RDS backups obviously must be backups of your RDS database instance, and then they can only be restored into an RDS database instance, whereas again RMAN works for RDS database instance in terms of yes, you can back it up, but then the restore will only happens for an external Oracle database. It does not happen for an RDS database instance. So the flow of RDS database, let me see the diagram one more time. So it does not happen for an RDS database instance, and so the flow in RDS database instance of Oracle to RDS backup to RDS database instance of Oracle, or RDS database instance of Oracle to RMAN backup to Amazon is free to an external Oracle database. So that is living outside of RDS. Now there's nothing called real application clusters. So RAC, okay, real application clusters, RDS for Oracle does not support RAC. RDS for Oracle does not support RAC. It could be an exam trick. RAC can only be working on Oracle on EC2 instance, because you have full control of Oracle when you set it up on an EC2 instance. Oracle does not support TDE to encrypt data before it's written into storage, and DMS works on Oracle RDS. So you can do an Oracle database on premises that you want to replicate into the cloud. For this, you just use DMS to replicate and migrate the data from the Oracle database on premises or to the cloud. Okay, so now, and there are some other examples, exempts you need to know for the RDS for MySQL. So you can use the native MySQL dump tool to migrate a MySQL RDS database into a non-RDS MySQL database. For this, this external non-RDS database can be either on premises in your data center, or you can run it on your own, for example, on an Amazon EC2 instance. So you have the RDS MySQL database instance in your cloud, and then the target may be, for example, on premises, and simply you will use a DB admin, the MySQL dump tool, to export it, import the data back into where you want it to go, and then you start a replication mechanism between the two databases to synchronize the data. And then once the replication is done, you stop it and you stop the source database. So another feature for RDS is the RDS Proxy for AWS Lambda. So when you use a Lambda functions with RDS, they actually open and maintain a database connection. And if you have many Lambda functions executing concurrently, then you may happen to encounter too many connections exceptions. So if you use RDS Proxy, you don't no longer need code to handle cleaning up idle connections or managing connection pools, because this is done by proxy itself. The proxy supports IAM authentication or database authentication, and auto scales So you must make sure that the Lambda function has connectivity to the proxy by either having a public proxy in a public Lambda or a private proxy in the private Lambda in a VPC. So a diagram will help you to, let's say, I'm sorry, my viewer was might be not available for like few seconds earlier. So let's start from where we have left. So let's say we have Aurora database cluster and a private subnet. We create an RDS proxy in a public subnet and Lambda functions which are operating publicly right now and came through IAM access and the RDS proxy and therefore access the Aurora database cluster. So the one that is being hidden from my view is the Aurora database cluster is. Now finally, one solution architecture we have already seen, which is how to do a cross-region failover of the RDS instance. It would be better to check the database health either using an instance, for example, that has a /health DB route, health-DB route to check or a CloudWatch alarm. So these things would be checked by a Route 53 health checks that would be linked to a CloudWatch alarm and that would trigger a CloudWatch event and this CloudWatch event would trigger Lambda functions. So whose role would be to update a Route 53 DNS for the database and also promote a read replica that is maybe in another region, for example, US West 2. So we have a cross-region replication in this instance, and then we have effectively created a cross-region failover architecture. So this is something very common that you shouldn't have for RDS, but we already seen this in the detail, and that's it here for the RDS, and it's really high level launch to know for the exam, but you should know by now. And so that's it, and I will see you in the next lecture.